So now we will discuss code blocks in Python. Uh, to start with, I am going to write down code for if-else statement, conditional statement, and I am initializing couple of variables here, a and b, to 1 and 2. It is a valid statement in Python, so when I execute it, it works very well, and I can now write code to actually compare a and b using if statement, and I can simply write a is less than b, and I can specify, let's say, print a here, and if it is not true, then I will write print b here. So when I run it, then I will get value as 1. A is less than b. So in this code block, you can see I did not write any brackets, curly brackets, or anything to enclose this print statement. So I am using colon to denote that this particular statement belongs to if. So if I modify this a bit, and if I write like this and run it, then you can see it gives me an error. This error is indentation error, and the error is coming because the print statement is not indented well under else, and hence it is giving me error. So in order to work with Python properly, you need to indent your statements properly, otherwise it will give this kind of error. So please be careful whenever you are working, because there are no curly braces in Python, so hence you have to ensure that the indentation of the code block is correct, then only it will work fine. So if I just fix this again, and if I write, let's say, print b, again it will give me error, because here it is expecting this to be in the same indentation level. So I can just fix it very quickly now, and I can just move it here. Now it will print 1 and 2 both. So I hope it is making sense when you have single line within this if block, or if you have multiple lines within this if or else block, then you have to ensure that they are indented in the same line, then only it will work fine, otherwise you will get this kind of error. So this was conditional statement. Now I am going to talk about the while loop, and you can actually define while loop. Let's say I already have b, so this b is 2, and I want to print values, let's say some values of the variable. So let's do one thing, like let's write while loop, and I'm saying when b is less than, maybe I have I, let's say I define variable I, and I is less than b, I is less than b, and I'm initializing I to maybe 0, and I am saying I is less than b, and within that I want to print a, and I will increment I equals to I plus 1. So this will print a value. A is 1 in our case, and we have a as 1, and I will just quickly write here print is complete, something like print loop is complete, or while loop is complete, right? So now it will run. First time when it will run, then I will be 0, and second time I will be 1, and then it will print twice the values of a, so that will be 1 and 1. So that's why we got this output 1 1, and while loop is complete. So hope this syntax makes sense. It is very straightforward, like in any other programming language we have while loops. So similarly we can write loops in Python also. We have other options also of writing loops. So you can write for loop, and you can define a method like, let's say, range method. So this range method, if you see the documentation, you will find we can define the stop index or stop value where we want to stop. So let's say I define range as 10, then it will print between 0 to 9. So this is like printing 0 to 9. So I will explicitly print it through the for loop. So let's do one thing, for I in range 10, and then after that we have colon, and then I'm having print, and here I'm just specifying I, and then it will print 0 to 9. So this was one variation of range method. I can also have another variation of range method, which is like starting index and ending index. So I'm choosing this start and stop index. So I'm specifying for I in range, let's say 5 to 10, and I can print here again I, and I can run it again, and you can see we got values from 5 to 9. So last index is not included, that's why it is going till 9. I can also specify the step size. So this is the third variation of the range method, and I can say I want step of 2. So when I do that, then I get 5, 7 and 9. This is the step size. Last one is the step size. Similarly, we can always specify maybe a continue statement. We can specify the break statement. You can actually stop it after maybe value 7. So you can say if I is less than, or you can specify I is greater than 7, then I want to break out of it, and I will run it now, and it will print 5 and 7. So we can actually control the flow of the statement or the program flow overall through break statement, through continue statement. So all these things are possible. Similarly, we can actually work with the list also. We can specify like I want to, let's say, print few elements, but for printing few elements I will be using a loop. So I am saying for E in let's say my list, and the list is 1 comma 2 comma 3 comma 4, and I am actually having the print method here, and I'm specifying here, let's say I, and run it. Then you can see I'm able to print the values from a list also, or a collection. You can do that. Similarly, we can iterate through the dictionary also. So for iterating through dictionary, let's say I have a customer dictionary, and customer, let's say customer details, and in this customer dictionary we have let's say customer ID as a key, and the value is, let's say, customer name, and customer name is Bhavuk, and the key is 2, and then the customer name is Tom. So I want to iterate through this dictionary. So I'm just specifying Tom, Alice, and I will now write a loop for key comma value, and I will say customer details, and this is like items which are there, and colon specifying print a statement again, and then I am specifying key and value, and I am running it. So you can see I am able to print the key value pairs from the dictionary using this for loop. So this is another interesting way to iterate through the collection, specifically dictionary. So you can also write code for list comprehension. So till now, whatever we covered was very much similar to other languages like for loop, while loop, if, else. But there is another interesting Pythonic way of writing code, that is list comprehension. So in this particular list comprehension, we have a very nice way to actually work on a collection. So what is list comprehension? In list comprehension, we have like a new list getting created from the existing list. So let's say we have a list. So I'm defining a list 1 comma 2 comma 3 comma 5. Let's say I want to do square of each element. So you remember, like if I just do 2 multiplied by L and run it, then it will give me something like this, which is not what I was looking for, because I wanted to do maybe multiplication by 2. Each element I wanted to multiply by 2, or maybe I wanted to do squares. If I just change it to star star, then it will become square. But I don't want to work like this. It is appending the same elements together. So what I want is to fix this problem, and in order to fix this problem, I will write code. So I will be writing code in the form of list comprehension. So for doing that, I'm defining, let's say L new. L new is the new list that I want to get, and this is L new, and this list will be created using various elements. So let's say we have I as an individual element, and I want to multiply that with 2, and I am saying for in L, right? And when I do that, I can actually print my L new, and you can see we got the values 2, 4, 6, 8, 10. Can you see the for loop is here, and the transformation that we are performing is on the left side? So that is quite different from other programming languages. So that's why we call it like a Pythonic way of defining a new list or collection from the existing list or collection. And This is like very convenient, very much readable, very productive way of transforming your list and creating another one, right? So hope this makes sense, and if you have like any questions on this, feel free to ask in the discussion forum. But I'm just thinking like, why not we also cover one more aspect here, which is like Elsif. So we just saw the example of if else, and we can also define Elsif. So I can simply write here L if, and the condition, let's say A equals to B, and I can print both are equal. So both are equal. Okay, so now before we do anything, I just want to show you what is the value of A and what is the value of B. So I'm just printing A comma B, and I have 1 and 2. So right now A and B, they are having these values. So let's run it. So it is right now showing me 1 and 2. Let's try to execute this statement by changing A and B to a value. Let's say A comma B equals to 2 comma 2, and I run it, and I copy this again, and I will paste it here, and I will run it again. So now it is showing me both are equal. So that means my else if condition is working well. Now there are other cases also in Python wherein I can write my code in a single line. So in other programming languages, you must have heard about ternary operators, or like in C, C++, we do have these kind of inline functions or single line operators. So Python does not support ternary operator. So if you try to do this thing, like if you try to, let's say A is 1, and you say that if A equals to 1, then you can say this is a low value. If you try to do that, otherwise you will say this is of high value. Let's say I have this. If you run it, then it will give you error. This ternary operator is not supported in Python. So if you want to implement single line, if it is possible, so you can actually write like this. So you can say copy. This is what I was expecting, like this is a low value because A is 5. So I am saying if A equals to 1, so then you print this, else we can say this is a high value. This is a high value. So if you run it, it works very well. So it is saying A equals to 1. So this is right now, what is the value of A? Let me print it. The value of A is 2. So that's why it is showing me this is a high value. So this is single line if statement that we can write in Python. Similarly, in Python, we can write code in try-catch block, and we can specify like, let's say I try to implement something like try, and then some code that I want to implement here. So I can have L, we already have L. So I can simply say that for I in L, and I want to print this I, and I can say that I equals to 0. and I can specify here except exception block. This is exception block, and here I am writing print exception occurred, exception occurred, and I can write here finally, maybe I can write something like print cleanup done, cleanup done, something like this. When I run it, then you can see it is working fine, there is no exception. But now let's simulate one scenario wherein I will try to create some exception here. So we can use one thing like we can say instead of 0 I am saying instead of, so I am saying I in L, and I can say I want to go far beyond what is supported, and let's say too far, and I'm defining length L, and let's say L plus 1, and I'm saying I in range, and this range I'm defining from 0 to too far. Yeah, so I am trying to reproduce an exception here. So I will specify here L and index out of bound exception I'm expecting. Okay, so you can see I am able to get an exception here, and this exception occurred because I am going beyond the length of the L, and it is saying exception occurred. So it is now caught in the except block, and there I am able to handle it gracefully rather than letting it fail abnormally. The program should be handling the exceptions gracefully. So that is one of the best practices. So whenever you work with Python, so try to handle the exception in the try, except, and finally block, and do the needful before the program exits abnormally. Yeah. I will be talking about the functions in Python. How do we define user defined functions, and how do we write anonymous functions? So that will be the next discussion which will be coming up.